Welcome to MRL. In this learning session, we'll learn to derive the important formulas used in coordinate geometry. We'll be learning to derive the distance formula, section formula, area of triangle formula. Let us begin. Now let us learn the derivation of distance formula. We already know what is distance formula, so let us derive it. Now we are given a x1 y1 and b x2 y2 are 2 points in a coordinate plane, and AB is joined. We have to find the distance AB or establish the distance formula. Now the construction is draw AM perpendicular to OX, BN perpendicular to OX, and AC perpendicular to BN. That's what I have written here. Now we get a triangle ABC, which is the right angle triangle, and by Pythagoras theorem we have AB square is equal to AC square plus BC square. Now AC and MN are equal because MN AC or AC and M is a rectangle, and therefore AC is equal to MN, and therefore I have replaced AC square by MN square. Now BC is BN minus CN, and therefore BC square will be BN minus CN whole to square. But what is MN? MN is ON minus OM. That's what I have replaced it by ON minus OM whole to square, and BN minus CN whole to square as it is. But what is ON? Now if you look at ON, this is the x2 coordinate. This is x2 coordinate, therefore I have replaced ON by x2. And what is OM? It is x1 coordinate. I have replaced OM by x1, so it is x2 minus x1 whole to square, plus what is BN? BN is y2, therefore y2. CN is nothing but AM, therefore AM is y1, and therefore CN is y1, therefore y2 minus y1 whole to square. So we get AB square is equal to x2 minus x1 whole to square plus y2 minus y1 whole to square. Therefore AB is equal to square root of x2 minus x1 whole to square plus y2 minus y1 whole to square. So that is what is the required distance formula, and we already learned about distance formula and its applications in our previous learning sessions. Okay, remember that. Now let us proceed to derive the section formula. We already know what is section formula, and also we know how the section formula is used and for different purposes. Now we are given a x1 y1 and b x2 y2 are any 2 points in the coordinate plane. CXY is the point on AB. The line joining A and B is AB, and CXY is the point on the line AB which divides line AB in the ratio m is to n. Remember that. That's what I have written here. Now the section formula is formula to find out the coordinates of the point C, that is CXY. So now or we have to establish the section formula. Now the construction required are draw AM perpendicular to OX, CQ perpendicular to OX, and BN perpendicular to OX, and also draw AP perpendicular to CQ and CR perpendicular to BN. Now by that we get two triangles ACP and CBR. So we have two triangles here, ACP and CBR. Now these two triangles, now please understand these two triangles are formed here. Now what we have to prove is the section formula. So for that we'll consider these two triangles, that is ACP and CBR. Now if you look at ACP and CBR, their corresponding angles are equal because this is 90, this is 90. Angle A and angle C are corresponding angles. Angle C and angle B are also corresponding angles, and therefore the three angles of this triangle, that is ACP and CBR, are correspondingly equal. Therefore triangle ACP and triangle CBR are similar by AAA similarity. Now if the two triangles are similar, the corresponding sides will be proportional, and therefore we have AC upon BC is equal to CP upon BR is equal to AP upon CR. But what is AC upon BC? AC upon BC is m upon m is to n, and that is m upon n, and that is equal to m upon n because AC upon CB is equal to m upon n. AC upon CB is m upon n. So remember this relation. Now let us take AP upon CR is equal to m upon n, that this relation, this ratio and this ratio, that is AP upon CR is equal to m upon n. So that's what I have taken here. AP upon CR is equal to m upon n. But what is AP and what is CR? AP is MQ and CR is QN. CR is QN. But what is MQ? It is OQ minus OM. And what is QN? It is ON minus OQ. That's what I have written here. OQ minus OM upon ON minus OQ, that is m upon n. But what is OQ? OQ is, please understand here, OQ is the coordinate x, and that is what I have written here, and OM is x1, ON is x2, and OQ is x. So I have taken the x coordinates of these distances, and that is equal to m upon n. Now simplify this, cross multiply x minus x1 into n, x2 minus x into m, that is m into x2 minus x and n into x minus x1, and open these brackets and simplify, rearrange, we get x is equal to mx2 plus nx1 divided by m plus n. So we have found out the x coordinate of the point C. Now let us take the next ratio, that is Cp upon Br is equal to m upon n. I have taken Cp upon Br is equal to m upon n. But what is Cp and Bp? We have to find out. Now what is Cp? Cp, please understand here, we have to find out Cp. So Cp is equal to Cq minus Pq, and Br is Bn minus Rn. Now Cp is Cq, and what is Cq? That is the y coordinate here. So please understand, this is the y coordinate, and Pq is the y1 coordinate, and similarly Bn is y2 coordinate, and Rn is again y coordinate. So therefore I have replaced them with y minus y1 and y2 minus y is equal to m by n. So this is the important relation which we have to establish from the diagram, and now cross multiply them, we get n into, in the bracket, y minus y1, m in the bracket y2 minus y, and then opening the bracket we get ny minus ny1, my2 minus my. Simplifying and rearranging, we get y is equal to my2 minus plus ny1 upon m plus n, and therefore cxy is equal to mx2 plus nx1 divided by m plus n, we have got it here, and y is my2 plus ny1 upon m plus n. Therefore remember, the coordinates of the point C, which divides the given line segment joining ax1 y1 bx2 y2 in the ratio m is to n, is cxy is equal to mx2 plus nx1 divided by m plus n, my2 plus ny1 divided by m plus n, and that is what is the required section form. Now let us learn the derivation of the area of triangle formula. Now we are given a triangle ABC. The coordinates of A are x1 y1, B is x2 y2, C is x3 y3. Now we have to find out the formula to find out the area of the triangle ABC. Now the construction is, draw BQ perpendicular to OX and AP perpendicular to X and CR perpendicular to OX. That is what I have written here. Now to find the area of triangle ABC, it is very simple. Take the two trapeziums, you see here, trapezium that is ABQP is one trapezium, and trapezium APRC is the second trapezium, and the third trapezium is BQRC. So if I add the areas of these two trapeziums and subtract the area of this third trapezium, I will get the area of the triangle ABC. Therefore I have written here, area of triangle ABC is equal to area of trapezium ABQP plus area of trapezium APRC minus area of trapezium BQRC. So that is what I have written here. Now we already know the area of a trapezium is half h in the bracket a plus b. So for each trapezium I will be applying that formula. Now we have area of trapezium ABQP is equal to half into PQ. There is a h is PQ here, and the two parallel sides are BQ plus AP. That's what I have written here. Now the area of the second trapezium is half into PR. PR is the perpendicular distance PR, and the parallel sides are AP and CR. So half into h in the bracket a plus b, and subtracting the area of the third trapezium, that is the height is QR, and the parallel sides are the BQ and CR, so it is BQ plus CR. So that is the area that I have written here. The sum of the two trapeziums areas minus the area of the third trapezium is written. Now half is common, so I have taken half common here. But what is PQ? PQ is OP minus OQ, OP minus OQ. And what is BQ? BQ is Y2, so I have written here Y2. And what is AP? AP is Y1, I have written Y1 here. Now PR is OR minus OP, so I have written OR minus OP. And what is AP? AP is Y1 and CR is Y3, I have written there. Now take QR. Now QR is OR minus OQ, OR minus OQ, and BQ is Y2, and the BQ is Y2, and CR is Y3. That's what I have written here. Now OP is x1 coordinate, OQ is x2 coordinate, so I have replaced OP and OQ by x1 and x2. And the next we have y2 plus y1 as it is. Similarly OR is x3 and OP is equal to x1 and y1 plus y2 as it is, and OR is x3, OQ is x2, x3 minus x2 in the bracket y2 plus y3. Now multiply these brackets. We have got x1 into y2 plus x1 into y1 minus x2 into y2 minus x2 into y1. Again we have got x3 into y1 and plus x3 into y3 minus x1 y1 and minus x1 y3, minus into plus is minus, that is minus x3 y2, so minus x3 y2, then minus x3 y3 minus x3 y3, minus into minus is plus x2 y2 and plus x2 y3. Now we observe here x1 y1 cancels with x1 y1 because plus x1 y1 minus x1 y1, minus x2 y2 cancels with plus x2 y2, minus x2 y1 minus x2 y1 it doesn't cancel, x3 y3 cancels with x3 y3. So the remaining terms are x1 y2, x2 y1 minus x2 y1 plus x3 y1, then we have got minus x1 y3, then minus x3 y2 and then x2 y3. Now bring the terms with x1, similar terms x1, that is having x1, bring x1 y2 and x1 y3 together, bring x2 y1 and x2 y3 together, and bring x3 y1 and x3 y2 together as I have written here. So take common x1, so we get half x1 in the bracket y2 minus y3 plus x2 in the bracket y3 minus y1 plus x3 in the bracket y1 minus y2. So that is the area of the triangle ABC which is given to us. Therefore remember, the area of triangle ABC is equal to half times x1 in the bracket y2 minus y3 plus x2 in the bracket y3 minus y1 plus x3 in the bracket y1 minus y2. Learn and remember this particular formula to find the area of a triangle ABC. The coordinates of the vertices are, when the coordinates of the vertices are given to us. So that is what is the area of triangle formula, a very important formula for us to remember, and it has its own applications which we already know and